Okay, our next area of focus was all about correlation. When you're looking at correlation, what you're really focusing on is that R value. Remember that the R value measures the strength of your scatter plot. So when we were talking about this correlation, we said that the units don't matter, so we got rid of them. We standardized both of our values, meaning we changed everything into z-scores. And then these z-scores came together to give us that R value, which is our correlation. Okay, the sign of the correlation always gives you the direction. So if you have an R value that's negative, you know that that scatter plot is going to be negative. If you have an R value that's positive, then you know that your scatter plot's going to move in a positive direction. The closer that your R value is to 1 or to -1, the stronger it is to a linear formation. The strongest R values are 1 and -1. So +1 would mean your dots fall in a perfectly straight line going in the positive direction. -1 would be the same thing, just moving downwards. Correlations of 0 indicate a weak correlation, so that would mean that there's absolutely no form or pattern. My dots are just all over the place. Okay, after we looked at that R value, we then did switch gears and we looked at R squared. R squared doesn't really have a special name, but I do want to point out that we should memorize this sentence again, which is the interpretation of R squared. Okay, R squared, you would plug it in right here, tells you the variation of y is contributed by the variation in x. So I would say 14% of the variation in heights is due to the variation in weights. You definitely want to know this sentence for R squared. If you're making like a cheat sheet as you're going through this review, this is definitely one that I would write down. This is something that we need to memorize. Okay, the only conditions that we have for our scatter plots, just make sure that your data is quantitative, and you do want to make sure that you have 2 quantitative variables. Make sure your data is straight enough, and you want to make sure there are no outliers. If you have curved data, it doesn't make sense to make a line of best fit, so make sure that you're checking for that straight enough scatter plot. Okay, a lot of the scatter plot is done on your calculator, so there's a few things that I want to go over. Okay, the first thing is if you are asked to construct a scatter plot for a given data set, in your calculator, you are going to start with typing in this data into your stat. So I'm going to go to stat, edit for enter. I would type in my first variable in L1 and then my second variable in L2. So this means I am using this is looking at locations of planets and then the distance that each of them are from a star. So I'm going to be using position number to estimate the distance from the star. Once I have my data typed into my calculator, I can now create that histogram. To create the scatter plot. To create the scatter plot, I'm going to be editing my stat plot. So I'm going to hit second y equals. I'm going to first make sure that this plot is on. Scatter plot is the first option on your list. And then you want to make sure you indicate where you're pulling data from. I'm pulling from L1 and L2. Once that's all set, we can go ahead and press zoom 9, and it gives us a scatter plot. Now, if you're asked to construct this by hand, when you go to sketch it, make sure that you have your axes labeled. So this would be position number, and then this is distance. You don't really need to, most of it will say just sketch, so I don't need to worry about a scale, but then I'm good to just start drawing in my scatter plot. I would include a title here, so I'm going to say distance from star. Once you have that scatter plot, then we can go ahead and do all of our describing. So when you're writing the description for this, that's when we're using that DFSU. So I would talk about direction, it's positive. Form, this is very clearly curved. And then strength, this is actually, quite strong. They are pretty close together, but in a linear fashion, it might be a little bit weaker. So I would say it's strong in the curved fashion. Unique outliers, I'm not seeing any, major outliers here. It might be an outlier if it was like up there, that's kind of unexpected, but I'm not seeing any outliers here, so I wouldn't need to indicate one. I have a few other things to recap on that calculator. We can make the line of best fit from this calculator, which we'll talk about that line of best fit a little bit more in the next video, but I do want to talk about how to find it on here first. So when you're trying to find that line of best fit, you're going to go to Stat, Calculate, and we're looking for a line of best fit, which means I'm looking for a linear regression. Again, pulling data from L1 and L2. Okay, now hopefully you're noticing mine only gives me my slope and y-intercept. So the slope is 449.77, y-intercept of negative 1,000-ish. Usually it gives me r and r squared here. If your calculator is not giving you r squared, you will need to change that. So on our calculator, what we're going to do is go to Mode. I'm going to scroll down until I see Stat Diagnostics. It's usually way towards the bottom. And you want to make sure that that Stat Diagnostics is on. Okay, it might be on right now, but if your calculator dies or you change your batteries, it does sometimes turn that Stat Diagnostics off. So you want to make sure that you're able to change that on your AP exam. Once on is highlighted, I can now go back to my Stat, Calculate, Linear Regression, and once I calculate, it should give me both my R value and my R squared. So again, this R value is telling us that this is quite a strong relationship. It's 0.91, so it does look pretty strong. And this R squared is telling me that 82% of the variation in distance is due to the variation in position number.